Hello and welcome back. We're jumping into Chapter 9, Section 7, the Law of Sines. When last we were together, we were doing trigonometry with sine, cosine, and tangent. And now we're going to go into a kind of a particular case, but a more general case. We're going to go into a use of something called the law of sines, and 9.8 is going to be the law of cosines. For our intentions, we have no law of tangent. It's kind of complicated why we don't. But just wanted you to know that that is on the horizon. So today we're doing law of sines. It should be a quick one. Let's talk about it. Let's talk about what the law of sines is. I'll do a little title up here in orange maybe. So the law of sines is a rule, a kind of property that we can use, and it is this. It is the sine of A over A equals the sine of B over B, and then the sine of C over C. That's a capital C and a lowercase c. So it's actually a three-part thing, and what it does is it gives us a way to solve parts of any kind of triangle. Now, if you remember before, when we did sine, cosine, and tangent, we had to have a right triangle. Well, the important thing with the law of sines and law of cosine is we can do this on any triangle. That was not the case for trigonometry. It's still, what's actually happening under the hood is right triangles still. I won't explain how, but it's still talking about right triangles. So we have a new law that we can use for not just right triangles. We can use this for just about any triangle. Sine A over A, sine B over B, sine C over C. I'm going to draw a simple diagram to match this so we can start unpacking what this means. So let's just use this triangle. Capital letters are vertices, there are corners, there are angles. So the sine of A, B, and C. And then the sides are the lowercase ones. They are opposite. So A is over here. It's opposite A. B is opposite B. And C is opposite C. So the sine of A over A is a proportion. It's a ratio. So you could think, and this goes back to what we talked about before, where if this angle is the biggest, this side will be the biggest. If this side is the smallest, this angle will be the smallest. This is the law of sines, and what we're going to do is just have a simple ratio we are solving. So the problems today really are going to be no different than something like this. They're really going to be no different than 4 over 9 equals x over 15. That kind of problem is what we're going to be doing. We have this sort of system that we're finding, because if you see, when we have the law of sines, law of cosines, it's going to look like this. It's going to be two ratios. If you remember how to solve stuff like this, very commonly we will just cross multiply. So this will become 4 times 15 equals 9x. 4 times 15 is 60. And we can divide by 9. And that is x is equal to 6.667, we'll say. Something like that. That is the kind of thing we're going to be doing. We'll put in some sine and cosine, but that kind of problem where we have a ratio we are solving is all we're doing today. So hopefully that is very clear. Let's move on. If you need it, please go back. Please stop the video right here. Pause this so you can copy down for your notes. This is the main idea today. These are all the notes. Now let's go on to a problem and solve it. We're going to do 3 problems today. I hope you write each of them down and try them on your own. Especially if you feel comfortable, try it before I do it, and then you can follow along and see how close you were. Here's our first problem today. We have angle ABC. This is triangle ABC. We have angle A is 58, angle C is 35. We could find angle B. At this case, we actually don't need it. Once again, we could do it, taking away 180, but I'll show you why we don't need it. In this problem, we are looking for pairs. We're obviously looking for this answer. That's our final answer. And we have its opposite angle. That's like a little pair. Remember, opposites are connected. They are like little dancing partners. We have this angle and its opposite. So we actually have enough to solve this with the law of sines. Law of sines is going to tell us we only need 2 of these. We don't need to do all 3. It's just telling us we have the possibility to use any of the 3. So we don't have to have a C term. We don't have to have a B term. We can just use 2 of them, whichever ones we like. In this case, we have an A and a C term. So I'm going to write it out generically and then plug our values in. Remember, that's a lowercase. All right, so let me plug in our things. Sine of 58 over 9 equals the sine of 35 over x. Now, you should have an idea of what kind of number this is going to be, what size number this is going to be. If we put a 58 into our magical angle box and it spits out a 9, putting in a smaller angle like 35 should give us a smaller side. How much smaller? We don't know. We're about to find out. But we should not get a number bigger than 9, right? Because these are connected and these are connected. Okay, great. We have a couple options. I'm going to turn these into decimals. I don't want to use the trigonometric terms from, like, this doesn't feel like a real number to me. So I'm going to turn those into numbers, and then that way I can just solve it like the very simple problem we did at the beginning. Sine of 58 is 0.8480. You can look on your sheet. Over 9. You could clean this up by itself. I'm just not going to do it that way at the moment, but that is okay as well. 0.5735. Now, these are not right triangles, and how it works is kind of confusing. We're kind of taking these and rearranging it on a circle with a right triangle. Don't worry about it. It's law of sines, law of cosines. We use it without a right triangle. So my next step is I took these and I looked on my sheet or I put in my calculator to get these values. If you did not get these, you got strange numbers, double check the mode button that's right here and make sure you're in degree mode. If you do not have degrees on, you will be in a little bit of difficulty. Okay, we are out of geometry land and into algebra world. All I'm going to do is cross multiply and then solve. At this point, we are out of geometry world. So 9 times 0.5735 is 5.1615 equals 0.8480x. 0.8480. Divide on both sides. 8480. And then my final answer. Remember, we're looking for a number smaller than 9. We put in 58 degrees, we got 9. If we put in a smaller angle, I should get something smaller, and I get x to be about 6.068. I'm going to round to one decimal place, 6.1. And we get 6.1. Great. That is an example of the law of sines. That's all we're doing in this section. All we're doing in this section is using those ratios to find missing pieces. We will use different directions sometimes. Like sometimes we're going to find an angle at the end of today. But right now, we are looking for a side. Sides are a little easier than angles, but we'll do the angles as well. So what I would like you to do, I'm going to put on another problem in just a second. I would like you to try it for yourself and see if you can get the answer. I will do it in a moment. They have different numbers, but different letters, but that shouldn't interfere too much. We have 37 degrees over here. That's a 37. 59 degrees over here. 98.4 and side D. So if you would like, I would like to pause the video, give it a shot, take a couple minutes. It is okay to not get it right. I think it's better to try it and see what you know already, and then jump back in. Okay, so I will start it now. We have all the pieces we need. Hopefully you can start to see when we are given things we don't, if we're given not the right pieces of information. For example, I'm going to find this to show you an example of how it would have been a little bit harder, one step harder. This is around 84 degrees. If we weren't given 59 and we were given 84, of course we could find 59. That's fine. The reason we cared about 59 is because we wanted opposites. Obviously we need to find this side, so we need this angle. So we needed another pair to play with it. We don't know what CD is, and we actually don't have enough, we don't need to find it in order to find D. That would be one extra step. We could do that, but we're not looking for C to D, so that's why we like having these pairs. We don't need 84. They conveniently left 84 out of the problem. So I'll set it up, and then we'll solve it. We have the sine of C, 37, goes over 98.4. If you want a way to remember it, sine of A over A, for example, the sine goes on top. It's kind of like a billboard on a highway. The sine is up top. I don't know if that helps. Great. If not, pretend I never said anything. And then we have the sine of 59 over D. So we're one step away from just being algebra. I'm going to turn these into decimals. If you want to turn this whole left side into one number, like you put this whole thing in your calculator, you can. For this example, I have not. But I am totally okay if you do, if you know what you're doing algebraically, which you should. Sine of 59. 0.8571 over D. So there we are. That is all the geometry we needed, and now we just have a ratio we're solving. It's got some decimals. We don't love decimals, but it is not too difficult. We're going to cross multiply right here. 98.4 times this decimal gives me 84.3452, 0.6018 times D. If you notice, I'm keeping decimals while I'm working. But I'm leaving them off of my final answer. So I've been keeping them as I go, but I just really, on my final answer, I can kind of shorten it. But if I start shortening every step, I'll start losing a little bit of accuracy. So I try to keep as many as I can while I'm solving it. 0.6018. Now, what I'm going to do is remember what kind of number I want to find. Do I want something bigger or smaller than this? Well, the magical angle box gave me 37, spat out 98.4. So 59 should be something bigger, pretty significantly bigger. So I'll do 84.3452 divided by 0.6018. And I get a number that is bigger. 0.154. I'm going to change that to 0.2, to one decimal place. All right, that is our first version of these problems. That's when we find a side. This is a little easier than finding an angle, but you're going to find the angle very easily, I believe. All right. Last part. Let's find an angle using similar ideas. We're not going to be doing anything different. We are going to be using our same ideas. So if you would like to copy this down, make sure you're copying everything down. If I'm going too fast or if you missed something, go back and double check the video. We are looking for this side, one second, I think I'm supposed to be looking for an angle. Oh, yes. Okay. So let's do this. I'm going to make up a problem looking for the angle. That is another problem that I do not want to look at the moment. It's a very similar one that we talked about with the 84. Okay, let's solve for our angle. Sorry about that. Mm-hmm. 18, 16.5, and then let's say this is x degrees, and then we will call this one something like 70 degrees. Okay, great. This may not be to scale. I just put that down, so maybe if it's not perfectly to scale, that's okay. It should work out though. We have a triangle, we have one given angle, one unknown angle, and two given sides. We have all the pieces we need. If we look here, 18 and 70, this little pair is intact, and x and 16.5, that pair is intact. Those are the two we need. Let's set them up. So the sine of x over 16.5 equals the sine of 70, angle goes inside always, over 18. Now, I can turn this into a decimal, like we did before. I cannot turn the sine of x into one. That one's just kind of stuck, unfortunately. This becomes 0.939 6 over 18. Okay. Now, with this kind of problem, I sort of reached an impasse. I can cross multiply, but because this is still here, it's just kind of going to make cross multiplying not as useful. It's not going to clear everything up. That's why this time I'm going to actually clean this side up. I'm going to clean this side up by just plugging this in my calculator. 0.9396 divided by 18 to get a whole new side. Just going to clean up that side by plugging in the calculator to get what that equals. 0.0522. I'm keeping 4 decimals while I'm working, and then I'll cut them off at the end. Okay, well, what's my next step? What other things can I do to try to get this by itself? Well, I'll get rid of the denominator. I'll multiply both sides by 16.5. And I end up as the sine of x is equal to 0.8613. And now I'm here. If you remember, we landed somewhere like here in the previous section when we were talking about trigonometry. How we do this, we have 2 ways to do it. Number 1, we can use our calculator. I'll do that in this moment. The other one is use our table. If you have your table, great. I recommend using it. We're going to look this up. So we're going to go to the sine column. We'll go down until we find something like this number. If you're using the table, we're going to be limited to what we can use. So we'll either have to pick right in the middle at like 0.5 or just kind of pick one of the closest number. On the calculator, what I'm going to do is do what's called the inverse sine. Remember, inverse sine just says look it up on the table in your calculator. 8613. So I'm going to go over here, second mode, or second sine. That's going to give me this inverse sine. And then I'll plug in that decimal. And my x is 59.47. And what that is an angle. So I'll round that to 59.5 degrees. It's a little harder this way, like I said, just because you're having to do a looking up on the table. It's going to fit right in between 59 and 60. So if you're looking at the table, use that. If you have your calculator, it'll give you the exact angle measurement. But I hope this made sense. I hope the law of sines is pretty straightforward. A lot of these questions came from your book. And I think if you do a little bit of practice, it'll start to make a lot of sense. Thank you guys very much, and I'll see you soon.